Jai Hind everyone, my name is Kamini Tanwar. I am assistant professor in IT department in AKGEC Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss a topic from the subject programming for problem solving. This topic is basically, this is the topic, that is algorithm, flowchart and pseudocode. I am going to explain here about the algorithm, what are the algorithm, what are the flowcharts and pseudocode with some example. So let's start. Okay, before that, this is the subject, that is programming for problem solving, and this subject is basically taught in the first year in BTech. Okay, so what is algorithm? Algorithm is basically a step-by-step procedure to solve any problem. Okay, like suppose we are going to make a tea. So for making a tea, what we have to do, we have to follow some steps so that we can reach to our solution. Like for preparing a tea, we have follow some steps. Like first we have to on the gas stove, then on gas stove we have to put the container on which we are going to make the tea. Then we have add some water and the ingredient which are needed in the making tea. So then these are the steps. If we are skip any of the step, then we are not successfully achieve our goal, or that means we are not successfully getting the tea. So this is the basically steps we are following our same like this we are follow steps in our programming language. So problem like here this is the meaning of the algorithm. That what is the algorithm? Algorithm is step-by-step procedure to solve any problem. So here what is the problem? We have to focus about the word, that is problem. Here problem is basically any program that we are going to design in our program. So in our programming language, what is if I am talking about a simple problem, like suppose we have to add two numbers, like we have to add a plus b. So this is the problem, like sum of two numbers. This is the problem. So for solving this problem, like we are having a plus b, we are having sum of two number of problem. So we have to solve this problem. For solving this problem, we are going to design some steps. So what are the steps? That are the algorithm. Okay, so similarly, I am having the second definition here, that like an algorithm is a sequence of computational steps that transform the input into output. Like we are having this problem, sum of two numbers. So in this problem, what we have to do, we have to follow some sequence of computation steps so that we are transform our input. This is our input. Suppose this is the input, A and B are the input. Okay, and what we have to do, we have to sum these two number, and at least last we are getting some output. So for solving this problem from this to this is the input and this is the output. So to solving this problem from input to output, we have to follow some steps, and these steps are basically known as the algorithm. Okay, now the second okay, one more definition is same here. Now, like an algorithm provides step-by-step solution for giving a problem, for given problem. Okay, so this is the simple example for solving sum of two number. So this is the example. What we have to do, basically algorithm, as I earlier told that what are the algorithm? Algorithm is the step-by-step procedure to solve any problem. So for solving, here we are having a problem, that is finding the sum of two numbers. Okay, now what we have to do, we have to write down some steps here. Okay, so in algorithm, what we have to do, we have to write like step number 1. So at first what we have to do, we have to start. Okay, now then second, after starting our algorithm, if we are finding a solution of two number, then what we are needed means, if we have to find two numbers sum, then what we have to need, we need two numbers. Okay, because we need A and B, these two number, we have to do the sum of these two numbers. So we require two input A and B. So like this, in second step, what we have to do, input first number as A, and in third step, what we have to do, input second number say as B. Now we entered the two number like A and B, or we can say we have input. Now the fourth step is what we have to do. If we are having two numbers, then what we have to do, we have to do some computational tasks. What are the computational tasks we have to perform here? Like we are, what we have to do, we have to add two numbers. So in fourth step, we are doing the computational task that A plus B into sum. Our sum is done here, or we can say the computational task is performed here. In fifth step, what we have to do, we have to display the sum, means our output. We have to display our output. This is the final result we are getting. Okay, and at last sixth step, we have to stop our algorithm. So this is the simple example for finding sum of two numbers. So like this, we have to do our algorithms, or we have to make our algorithm for any problem. We can suppose in place of addition, if we have to perform some multiplication task, then what we have to do, we have to, this is the same procedure we have to follow. In first step, we have to start. In second step, if we are performing multiplication, again we needed two input digits. So A and B, suppose we have to perform multiplication between A and B, then input first number as A, input second number as B. In fourth step, what we have to do, we have to perform the multiplication task. That suppose I am taking a variable mul equals to A star B, or A multiplication B. Here I am performing the multiplication task, and then at last the display, that is important part. If we are giving some input and somewhere else, then after the computational, we are getting the output, final output. So this is the basic example for performing an algorithm or writing an algorithm. Okay. So the next thing is, what are the properties of a good algorithm? Because if you are writing algorithm, then there is requirement of follow these some property of the algorithm. So first property is input. What is input? Because if you are performing a algorithm, or you want to draw an algorithm, or you want to write an algorithm, then there must be at least one input in your algorithm. Because without input, you are not able to write any algorithm. So for performing any problem, for performing any solution for a problem, so we need a input. Okay. So first is our property is must have at least one input in our algorithm. And the second thing is, if we are giving input, then at least one output we must have. Because after solving a problem, you are not saying that we are not getting any output, or you are not getting any, or your output will be infinite state. No, nothing. We have to get a output in our algorithm. Means our problem must have a solution. So this is the output. This is the second property of an algorithm. These properties are very important for writing algorithm or for performing algorithm. Okay. The third property is our definiteness. What is definiteness? Definiteness is basically we are having a unique definition for preceding and exceeding steps. Means anything which you are declaring there. So there must be, the meaning must be clear for everyone. Because if your meanings are not clear, then how we will going to reach our output? Okay. So there must be the definite in your statements, or definite in your steps. That means clear meaning of each step. That is definiteness. And the fourth is finiteness. What is finiteness? Means the number of steps. Means number of step must be finite. Means if you are performing some operation, or you are performing some computational task, then we are giving input, then we are performing computation, and at last we are getting output. So these are the number of steps must be finite. Not that we are performing, and that the steps going on means we are using step number 1, 2, 3, and so on. This number of steps gone in infinite state. This is not correct. The step must be finite, because we are solving a problem. Means we must getting a solution for a problem. For getting a solution for a problem, there must be the number of steps must be finite. And the last one is the effectiveness. Effectiveness means each step must be step must be effectiveness. That means the step that as we are writing the algorithm, why we are writing the algorithm? To convert this algorithm into a program. So the steps that you are designing, that must be convertible into a program, that must be easy convertible to a program, not that much complex you are creating those steps, so we are not able to convert those steps into the program. For that, the step must be very effectiveness, or you can say that operation should be easy and simple. Okay, why we are taking these operations simple and easy and simple? Because at last we have to convert these steps into a program. Why we are designing the algorithm? The main purpose for designing the algorithm is, by using this algorithm we are going to convert these steps into the program. For designing a program, we are using this we are designing the algorithm. Okay, so these are the properties of the algorithm, and these properties are very important for designing the algorithm. So we must have to be focused, or we must take we must learn, or we must always in our mind that these are the property and these property must be followed as it is. Okay, so now the second term is our flowchart. After algorithm, means first we are having a problem. For that problem we are designing an algorithm. After designing the algorithm, what we have to do? We have to draw a flowchart. Now what is flowchart? Flowchart basically a graphical representation of any process. Okay, or you can say the symbolic representation of the algorithm. The algorithm we have designed. Okay, now we have to convert these algorithm into the symbols form. Like we are using some graphical symbols, and with the help of these symbols, now we are solving the problem. Okay, like say, means first we are writing this problem in steps. Okay, in the steps we are using in our algorithm is simple, like English steps. Okay, no need to require any specific language for that. We are using simple English language for designing these steps in our algorithm. Now we have done our algorithm part. Now what we have to do? We have to convert this algorithm into graphical representation form. Okay, now we are for representing these form into graphical form, what we have to do? We have to use some symbols. Okay, now what are these symbols? So basically, what are these symbols? We are using terminator. Okay, terminator is basically, we have to use a symbol for showing the starting and ending point of any algorithm or any flowchart. First, so for that we are using a terminator symbol. Okay, the terminator, for in place of terminator, which symbol we are going to use? We are using the oval shape symbol. This oval shape symbol is used for terminating any flowchart. What does mean terminating? Means the starting and the ending part of any flowchart. Okay, the second one is the process symbol. The basically process symbol is representing the activity of any process activity, and for this process, which symbol we are going to use? We are using the rectangle symbol. Process of any problem is the computational task where we are going to perform is basically with the help of this process box. The third one is data symbol. What is data symbol? Basically, data symbol is used to represent input and output in any flowchart. Means for any problem, we must give the input, and after computation or after processing, we get the output. So for showing the input and the output function, which symbol we are going to use? We are using the parallelogram symbol, like this, little bit tilt from both the sides. So this is the parallelogram symbol which we are going to use for showing the input and output function. The fourth one is the decision symbol. This decision symbol is basically used to show the decision or any condition where you are going to use in your problem. So that time we are using the decision symbol. So this decision symbol, which symbol we are going to use? This diamond box we are going to use. In this diamond box, we are putting our conditions or our decisions for performing any task. And the fifth one is our connector lines. What are connector lines? Basically, connector lines are to connect these are the line to show the flow flow of your program data, then where the data is going to be flow. And one more is here, this circle. This circle is basically connect all the lines that are flowing in our flowchart. So these are basically the symbols that we are going to use in our flowchart. And these important symbols, these are the important symbols. We must remind these symbols to design a flowchart. Okay. So this is the brief explanation about that I have earlier told about the symbols. Like first one is your oval symbol. You can say this is for the start and end. The second one is your input and output symbol, that is parallelogram, that is used for inputting and outputting the data. Third one is your process symbol, that is means your rectangle box that represent any process in your flowchart. Then the decision box, that is means the diamond box that is used for taking any decision or in your flowchart or in your problem. Then these arrows basically used to show the flow, where the flow is going, means like we like here this direction, in this direction or in this direction, where is your data is going to flow, in which direction. So with the help of these arrow, we are using these. We are basically with the help of these arrow, the data where the data is going to be flow in your program. So then, and the last one is the circle. Circle is basically connector symbols. Like we are having multiple lines, multiple in outputs from in our program. So for joining these multiple outputs, we are using this connector to getting a single stop. For single termination, we are using the connector lines. Connector lines is basically used for the representation, better representation or good representation for your flowchart. Now let's see one example for flowchart. I am taking the same example, like sum of two numbers. Before this is the example that I have already taken in your designing the algorithm. For the same, I am going to designing the flowchart. Okay. So first, what we have to do in our flow algorithm, what we have done, like in first step, we are starting, step 1, we have start. So with this start symbol, we are starting our flowchart. Then I am writing the flow algorithm of this problem that I have earlier discussed, but I am here comparing both so that you can easily getting the thing that I am here teaching. Okay, in step 2, what we have to do, what we have done in our algorithm, we have just input value A. That means we are entering any value. Okay, inputting the data A. And in third step, input value B. This is the third step. Okay, now compare. We in first step start, we have start the symbol with oval shape. Then we are taking the input with the help of parallelogram. Then second, again we are taking the input, again we are using the parallelogram. Now in fourth step, what we have done, we have doing our computational tasks, like sum equals to A plus B. So this is the computation task. So for computation or for processing, which symbol we are going to use? This rectangle symbol we are using. So after this, we are getting the final output for our problem, that is output sum, you can say, or display sum. So this is the print with using this again parallelogram symbol. We are showing our output here, and at last the stop symbol. So these are the terminators. Okay, like this. In step 6, we are stop our algorithm. So as you compare our algorithm with the flowchart, you can just, what we are doing here, we are converting these steps into the symbolic form, or you can say the graphical form. Like here we are using the symbols. So if you are just remove these steps here, we are not using this, and we just convert these into a, you can convert these steps in symbolic representation, and you can say this is the like this. So this algorithm is converted into the flowchart. So this is the example of flowchart. Next is our pseudocode. What is pseudocode? Pseudocode is basically, you can say, a high level language description of any program. Like first we have designed algorithm. After algorithm, we have convert these into the flowchart. Now our pseudocode. Pseudocode is basically nearest to the programming language. This code is basically a syntax of normal programming language, you can say. Okay, and pseudocode is your human readable form, not machine readable. What is machine readable thing? Machine readable means anything that is in the form of 0 and 1. That is machine readable, and human readable is anything that we can read easily. So pseudocode is similar, just similar to the programming, but without their syntax. Okay, so this is the pseudocode. Now let's see the difference between the algorithm and the flowchart. What are the difference between? Like algorithm, what is algorithm? Algorithm is the step-by-step processor to solve a problem. Means in algorithm we are using some steps, and in flowchart what we are using? We are using the pictorial representation of the any. Okay, these here we are using the pictorial representation, and in algorithm we are using the steps. Then second is, it is very easy procedure to represent logics in algorithm. Okay, means in algorithm, because this is the simple in the algorithm we are using the simple English, so it is very easy to represent logics in this. But in flowchart it is little bit typical to represent the logics as compared to algorithm, because we are using symbols, and in symbols it is very complex task to represent and every logics. Okay, so basically why this is happening? Because of the lack of symbols, because we are using the only 6 symbols in our flowchart. So for designing the complex problem, the task is very difficult for us. Okay, now it is easy to modify algorithm. Means suppose we have done some problem in a, or we have by mistaken any wrong thing, or any mistake we have done there, so it is very easy to modify in our algorithm. Okay, because we are just removing the steps and just updating that step. But in flowchart the modification is little bit difficult, because if you are changing in any symbols or in any flow, that means we have to check whole flow from up to down. So this is little bit difficult as compared to algorithm. So these are the difference between the algorithm and the flowchart. Now the next thing is, now let's see the difference between the algorithm and the pseudocode. Algorithm is basically, we know already that this is a sequence of steps that provide a solution for a given problem. And in pseudocode, what is it? This is one of the method that can be used to represent an algorithm. Like if I am talking about the main difference between the algorithm and the pseudocode is, like in algorithm we are using steps for writing algorithm, but in pseudocode we are removing those steps, and the start and stop steps, the between portion, means after removing the steps, okay, that we are writing the like steps, step number 1, step number 2, like this. So in pseudocode no need to write these steps. Okay, and also no need to write any start and stops, but the inner portion of your algorithm is like same as your pseudocode. Okay, that's why we are saying this is used to represent an algorithm. Okay, an algorithm can be written in natural language, but here pseudocode is written in format that is closely related to the high level programming language. What is high level programming language? Suppose we are in PPS, we are studying about the C language. So C language is your high level language. Basically this is a programming language that is used to perform some performing or solving some problems. So for these our system is understand the low level language, but human being is not understand these low level language. For that purpose the programming language is designing, so that human easily interact with computer and computer easily interact with human being. Because if we are dealing with the machine language, for human being it is not easy task to learn the machine language properly and then operate the computer system. For or you can, the interaction is very difficult, because we have to learn we have to study all about the machine language, and for that every system is required different machine language. So for that, this is very difficult task for us. So that's why we are designing some high level programming language like C, C++, Java, Python. These all are your high level programming language. So pseudocode is nearly or closest to the high level language, but algorithm is your natural language, like your English language. Okay. Third one is transforming an algorithm in programming code is difficult. Means little why it is difficult? Not that much difficult, but in comparing with the pseudocode, it is little bit difficult. We are comparing here with the pseudocode because pseudocode is just nearest to the programming language, so it is easy to convert. But algorithm is not that much as compared to pseudocode. So this is the difference between the algorithm and the pseudocode. So let's discuss some example for designing algorithm and flowchart. So here we are designing a algorithm for converting your temperature from Celsius to Fahrenheit and Fahrenheit to Celsius, vice versa. Okay. So what we have to do, our first step is, what are the variables we are using here? Means C for the temperature in Celsius and F for the temperature Fahrenheit. So this is the algorithm. First, what we have to do, we have to write down the steps. For writing this step, first step is we have to start the algorithm. After that, we are taking the input because we need an input. As you you have remember the properties of your algorithm, then you easily relate this. Then the second step must be your input, because if you are not giving an input, that means you are not getting an output. So we are performing your computation task on the input. So second step, we must enter the input, and then the third step here is your computational task. So here we are performing a computation task. So this is the simple formula for performing. As everyone know about this formula, this is used to convert the Celsius into Fahrenheit. If you want to, if you want to do the reverse, so that, okay. So this is the formula you have to follow. Then fourth step is to display the output and then stop. This is the algorithm, and for the same problem, the output is the flow chart is the same. This is the flow chart. Like for start symbol, input. For input, we are using the parallelogram symbol. For performing any task, we are using the process rectangle blocks. This is the process block or the stop. Okay, so this is the example for flowchart. So that's all for this lecture. We will continue with some more example in our next video. Thank you.